What is up, everybody? It's the Home Ec Guy here, and today it's kind of a rainy, miserable day. I was supposed to be doing a ground mount system today. That's not going to be able to happen when the ground's like pudding. So we're going to put that off and start doing that tomorrow. As a result, I'm going to go over different disconnects that we use and how they need to be wired in a grid-tied type system. So behind me here, I have two disconnects. I have a fused and a non-fused disconnect. This is something that I use all the time, that we wire all the time. This video is going to be mostly for like installers that are looking to install and learn about it, and also for designers that need to know this, because I get a lot of design drawings that are incorrect as well. So let's get the camera over here. I've already wired these. All right, so the first disconnect we're going to look at here is a non-fused disconnect. And a non-fused disconnect is something we use with the smaller systems that end up getting fed into a breaker in the house in the main panel. The other kind of disconnect we'll look at is a fused disconnect, and that's connected a different way. So when we connect something through a breaker, we're going to assume that our inverter is coming from the left side here, and that our main service panel, or the breaker that we're going to backfeed into, is out the right side here. Alright, so this is the bottom part of a non-fused disconnect. You'll see our ground comes in, and it comes in from the inverter off to this side. It connects here. It loops up. I give myself a little loop. Now, I don't make this as tight as I possibly can. I want a little bit of extra movement and wiggle in there, so it's not tight. This one connects back here. So our ground is connected here, and then it comes through and connects to our grounding bushing over here as well, before again it loops, nice loop, and then goes off into the main service panel, where it will be go to the ground rod inside the main service panel. Now if we look at this grounding bushing here, we see that the ground wire goes through here, and this screw tightens down on here. Now this screw here connects this to the bushing, this lug to the bushing. Now the bushing still needs to be connected to the conduit that goes through it, and that's what this screw does. So you need to have this bonding screw in order to bond this whole bushing to the conduit that's going to the next place, and that's the whole purpose of this whole bushing here, is to ground the conduit from point to point. Now you'll also notice on this one, my neutral wire just passes straight through and goes on to the ground or neutral bar in the panel where it connects at. So far we have a ground leaving here and a neutral leaving here. All right. So coming in from our inverter, we have our line 1 and line 2. Now it's important that line 1 and line 2 coming from the inverter go to the bottom of the disconnect. It's not as apparent in a non-fused disconnect as to why, but you'll see why in a second as to why it's important that your inverter comes to the bottom lugs, and then your top lugs will go out to your breaker, or to your breaker in this example. So now if we go up to the top, we have our line 1 and line 2. This comes up, goes out, and then goes down over to our breaker. Same with the black one. These go to the dual pole breaker that'll be in the main panel. So let's see if I can zoom out all the way here. So we have our full disconnect real quickly. Again, your neutral just passes through. Your green hits these 3 lugs. Your line 1 and line 2 come from the inverter to the bottom of the disconnect, and then out of the top of the disconnect over to your backfed breaker. And that is how we wire a non-fused disconnect. These wires are probably not the size wires you would use in this size disconnect. It's just for an example. Next, we're going to look at a fused disconnect and see how we wire them and how it's different, and talk a little bit about why. Alright, this is a fused disconnect. I have fuses sitting in front here. We're not going to install them right away. And as you can see right off the bat, there's a bunch more stuff going on here. So let's start. We're going to go here like this, get a little bit better view. Now the things that are the same we'll talk about right off the bat. Line 1 from the inverter at the bottom. Line 2 from the inverter at the bottom. Line 1 out the top over to our line side tap. Now on this, we're tapping the wires coming from the street before they get to the main panel. And so this is why things are different here. So this will go from here to out over here to the tap. Same with the black line 2, just like we did in the fused disconnect, or the non-fused disconnect. Now, with a fused disconnect, the groundings and neutrals get a lot different. As you can see, we have this bar over here that didn't exist before. Let me zoom in a little bit on that guy. All right, so when we look here, we have 3 lugs, and then right here there's a green screw. Now when you buy this, the green screw comes with it, but it's not installed. Now what this screw does is it goes through here and connects this whole bar right here. It connects it to the actual frame of the device, of the disconnect, and that's called a bonding bushing. It bonds this bar to the actual device. And the reason we're doing this is because now, as this is a tap from the main service that comes in from the street, this is called the first. This is considered the first place of connection. So now we have our neutrals and grounds connected and bonded all here together in this bar. So we have our neutral that comes from the inverter and comes up, and instead of passing through like it did before, it comes right here and stops right there. Then we have our neutral come out the top here, and that goes over to our main panel or wherever we're tapping at, and that connects and bonds there. We also have the ground here, as you see. Now before, the ground just connected to lugs at the bottom and passed through. Now what we see is the ground comes in, hits 1, 2, 3 lugs, but instead of going through here on the far side over on, it comes up and lands right here. And that's it. It doesn't go out here at all. Now, so coming out this side, we have our line 2, line 1, and our neutral, and that's all that goes over there. So in the non-fused disconnect, we had the ground, and all the ground continued on through, but instead, this becomes our grounding bar and the first point of interconnection from the street. So we land our neutral here, we bond our neutral and ground together, and then every point after that, it has to be separated in the inverter, which it is. And that is all that happens. Now, as I mentioned before, we would see why it's important that our line goes up to the top and our inverter comes into the bottom. And the reason is if I have my line, if this bottom part was going out to the taps or the breaker, or the taps for this, that would make this whole piece right here hot, and I couldn't touch it. That means when I put my fuses in, I could end up getting shocked, or more likely, when I take my fuses out, I'd end up getting shocked. So if my fuse blows and this comes out the bottom and goes over to the main taps, then this is going to be hot, and when I try to pull this out, that makes it hot, and that could be dangerous. Whereas if they're on the top, if your line goes to the top, and these are hot, and the disconnect is disconnected, then all of this down here is safe to touch. That's a huge difference, it's a huge deal, and it makes a big difference on, well, inspectors won't pass it, and it's a big safety concern. So those are the 2 disconnects that we use, the fused disconnect that we just looked at and a non-fused disconnect that we looked at previously. That's how they're wired. I didn't go through my actual process of wiring them. This is just more of an example of what it should look like wired. So if you're ever curious or you ever have a question and you're not sure about how something needs to be wired, then come back, take a look at this video, and it'll give you all the answers you need. If you have any further questions, make sure you leave them in the comments below, and I'll answer them as soon as possible. Thanks for checking out the video, and I can't wait to see you next time.